US Physics Olympiad, year 2011, F equal MA. First round. Problem 15. Solution for this problem you can find below this video, the reference in the description. A vertical mass spring oscillator is displaced 2 cm from equilibrium. The 100 gram mass passes through the equilibrium point with a speed of 0.75 meters per second. What is the spring constant of the spring? Solution. Here we can use energy conservation for oscillations. In the lowest point we have kinetic energy of system is 0 and all energy equal to potential energy of spring and gravity, which is 1/2 kx square, where k is displacement from equilibrium. And when this mass passes equilibrium point, in this point potential energy of system is 0 and all energy is going to kinetic energy, which is 1/2 mv square. So now we can write this equation. That's the equation from which we can find what is a spring constant. That will be this expression. When we put numbers, we will get 140 newtons per meter, which is answer D. Problems number 16 and 17. Questions 16 and 17 refer to the information and diagram below. Jonathan using rope to lift a box with Becky in it. The box is hanging off the side of a bridge. Jonathan is on the top. A rope is hooked up from the box and passes a fixed railing. Jonathan holds the box up by pressing the rope against a railing with a massless, frictionless physics textbook. The static friction coefficient between the rope and the railing is mu s. The kinetic friction coefficient between the rope and the railing is mu k less than mu s. The mass of the box and the Becky combined is m big, and the initial height of the bottom of the box and the ground is h. Assume a massless rope. Question 16. What magnitude force does Jonathan need to exert on the physics book to keep the rope from slipping? Solution. To keep a rope from sliding, Jonathan must create a force of friction equal exactly mg. So that's the equation. Force of friction equal mg. But maximum force of friction equal mu static multiplied by force which Jonathan can apply to press this rope. So that will be this expression. So from this two expression we can find that force exerted by Jonathan on physics book must be equal to mg over mu static, which is answer E. Question 17. Jonathan applies a normal force that is just enough to keep the rope from slipping. Becky makes a small jump, barely leaving contact with the floor of the box. Upon landing on the box, the force of the impact causes the rope to start slipping from Jonathan's hand. At what speed does the box smash into the ground? Assume Jonathan's normal force does not change. Solution. As we solve in question 17, the normal force created by Jonathan equal to this expression. But now, because this rope is sliding, we have a force of kinematic friction, which equal now this expression, mu kinematic multiplied by normal force. So that's the expression for new force of friction. And now we can count what is the equation for motion for Becky's box. This is the equation. MA equal mg minus force of friction, which is this one. And from here we can find what is acceleration for this motion, and that will be this expression. Now we know what is acceleration and what is the total height. From this data we can find what is final speed. Final speed square equal 2AH, and the final answer will be this one. So we see that the correct answer now is D.